This is an exciting time at Pratt Whitney. Pratt Whitney has developed an entire new suite of digital processes and technologies that will apply throughout the entire product lifecycle. And our vision for data use is one that's fully interconnected across the entire product lifecycle, from engine conception to fleet operation. We're driving a model-based enterprise initiative with the goal to improve our productivity, time to market, product quality, and user experience, just to name a few. But realizing the true rewards of our digital transformation requires a comprehensive approach stretching across the entire product lifecycle. From our conceptual design process, through our proposals, prototyping, full EMD development programs, through production, fleet support, maintenance, repair, and overhaul. Our vision connects the data, processes, plans, and predictions together, not just for one engine, but for entire fleets, cutting across organizational boundaries and covering our global footprint. The results, we believe, of taking this full life cycle approach right from the beginning will be to create unprecedented speed, efficiency, quality, value, safety, and reliability in every aspect of our products and operations. The first phase in our product lifecycle is the conceptual design process. Just like 3D solid models revolutionized the work that was previously done at a drafting board, digital technology is already transforming the way we harmonize engine and vehicle architectures to meet the overall vision for our customer. In the past, we worked in silos. Now, our customers want to jointly conceive and optimize architectures in real time, not just for the engine, but for the entire power and thermal management system as well. When the Air Force applies this digital Century Series approach that they've been talking about, we anticipate we can cut up to 90% of the cost and lead time from our conceptual design process, resulting in the ability to jointly evaluate hundreds, thousands, even millions of potential design solutions in real time. Working in our new collaborative model-based systems engineering environment will enable our systems engineers the ability to see the sensitivity of each requirement to the potential development, production, and sustainment cost of each proposed engine. Using this model-based systems engineering approach, we can accelerate from one iteration per month to hundreds of iterations per day. The next phase in our product lifecycle is the proposal and contracting phase. During one major recent proposal process, digital models were used extensively as part of the proposal and evaluation phase. It seems obvious that we'd want to replace physical pallets of paper as part of a large proposal, but our digital strategy goes far beyond that. Instead of offering one single point design to our customer, by using digital models, we offer them an entire range of solutions. This allows them to analyze and evaluate the best solution for them, instead of Pratt & Whitney trying to guess the winning solution. So ultimately, we transition from boxes of paper containing only one single proposal to a purely digital, model-based proposal that provides our customer an entire range of potential solutions, allowing them to choose the price, the lead time, and other features that create a winning program for them. When we enter the design phase, that's when we begin spending significant time and money, and where the Air Force is looking to create a step change in the overall approach, speed, and fielding of new aircraft. For Pratt & Whitney, this isn't only about creating the right sort of digital tools that allow our engineers to continue to streamline this incredibly complex work they do, but it's also about creating the environment and program structure for us to collaborate with our customers and suppliers. It's hard to talk about digital without also talking about agile. The way we're actually going to transform our product development process isn't just through these new model-based systems engineering tools, but also by enabling our people and programs to rapidly build prototypes, tackle the highest risks one at a time, and come up with the most robust product that they can. In multiple GatorWork programs over the last 3 years, we've demonstrated that this approach can save at least 50% of the cost and lead time in these early phases of a design program, while at the same time coming up with more innovative solutions. One of the other key factors in the lead time of any development program is the amount of lead time it takes to order development hardware. To tackle this challenge, the GatorWorks team has come up with an entirely new agile procurement system. Our team created a suite of new digital tools and process automation, which create an entirely self-serve process. Previously, it took up to 132 days to order a new piece of hardware in a development program. Today, we've reduced the timeline from 132 days to 7. Our ultimate goal is to bring that 132-day lead time down to just 1 hour. The next phase in our digital product lifecycle is what we call as-built. This is the production manufacturing phase of the product lifecycle. We recently announced the new turbine airfoil production facility in Asheville, North Carolina. Our investment in this plant will modernize and transform our operations with cutting-edge digital technologies. Our designs will come in digitally and the plant will operate semi-autonomously. This is part of our Industry 4.0 strategy and will strengthen our position by implementing modern solutions to prepare for the future. Another key element of our as-built digital manufacturing strategy is what we call the digital twin. Our vision for this digital twin is that every part that's manufactured, both in Asheville and actually across our entire supply chain, will be digitally scanned in, starting the process of building this digital twin. In GatorWorks, we're currently testing a unique digital serialization process. So when every part is manufactured, it becomes uniquely identifiable and can be tracked digitally across its entire life. The fifth phase in our digital product lifecycle is what we call as flown. This is where we support our customers in the field. One of the key digital elements that we've introduced recently is what we call the Fleet Command Dashboard. Managing a large fleet across the globe is a huge logistical challenge. The Fleet Command Dashboard allows us to instantly identify, triage, and resolve problems literally across the globe. Another high-impact example of supporting the fleet is the digital twin that I mentioned earlier. One of the use cases that we have in mind for our digital twin is to provide real-time visibility of engine usage, remaining part life, and to predict performance, spare part needs, depot capacity, and more. We have the capability to collect full flight data from onboard engines through advanced engine sensors, then merge those data with real flight situations in order to provide insights to engineering and maintenance teams both on and off wing. The use of the digital twin will allow us to monitor the utilization of each engine and actually fly forward to predict future maintenance needs. By doing this, we can develop tailored maintenance plans that are unique to each engine in the field. We've already demonstrated that the use of this digital technology can reduce the amount of time it takes to forecast spare part demand from 4 months to 4 hours. We can actually track the exact conditions that engine flew in. Every storm, every mission, every altitude, so that when it comes into the depot, we know exactly what its quality and durability are. The final phase in our digital product lifecycle is what we call as serviced. A great example of our digital strategy for servicing our fleet is what we call usage-based lifing. Now, lifing is the process where our engineers determine how long a particular part is safe and effective to fly. Usage-based lifing utilizes unique digital damage models combined with that digital data that we generated from each flight. The flight temperature, the pressure, the flow, the speed, the altitude, and predicts the correct removal rate for each part based on the real-world conditions of each engine. Our analysis shows that this will decrease the total number of overhauls required over the life of the program, resulting in a significant cost savings for our customers. In many cases, it will eliminate the need for the 4th planned overhaul, representing a significant savings in sustainment cost, which could be up to 10% of the savings in the life cycle cost of an engine. In addition, from a logistics and depot capacity perspective, We anticipate this approach will also smooth out the large peaks and valleys we typically see in overhaul demand. Using our digital models and digital lifing, we can smooth out this demand, which significantly reduces the cost and also optimizes the flow of engines through the depot. Because our strategy is to work across the entire life cycle of a program, our 6th-gen programs will start with these digital lifing algorithms right from the beginning. This will allow our customers to have significant savings over the entire life of their fleet. So taken together, Pratt Whitney has developed an entire new suite of digital processes and technologies that will apply throughout the entire product lifecycle. The introduction of these innovative new digital tools will deliver significant value to our customers in every phase of the product lifecycle, from conceptual design through fleet support, while we continue to deliver propulsion products that meet and exceed our customers' critical requirements.